Hey guys, welcome back to the channel. In a previous lectures, we discussed about various feature extraction techniques like bag of word and TF-IDF. Now in today's particular video, we are going to learn about the most efficient and most frequently used feature extraction technique, which is word embedding. So currently word embedding is used as a feature extraction techniques in each and every state-of-art model in NLP. Before starting this video, I highly recommend to watch out previous feature extraction techniques like bag of word and TF-IDF so that you can understand this concept better way. So let's get started with feature extraction techniques word embedding. So in previous lectures, we discussed that in bag of word and TF-IDF techniques, they process the text to find out how many times each words appear in the sentence. This is also called as a vectorization. But here as a output we get a sparse matrix. So sparse matrix means we got a lot of zeros in the matrix, which is called a sparse matrix, which is a highly inefficient matrix while we are performing internal computation. So here word embedding is useful to transferring these sparse matrix into the dense matrix, or we can say converting this high dimensional data into the low dimensional data, right? Here sparse matrix problem is solved by the mapping with high dimensional data into the lower dimensional space. Word embedding translates large sparse vectors into a lower dimensional space that preserve semantic relationship. So here word embedding is also useful for preserving semantic as well as the syntactic relationship between the words while we are converting the into the feature representation, or we can say vector form. So here we also want computers to build a relationship between each word in a sentence with other words in a sentence, right? As I have told before, it is preserving the relationship of semantic and syntactic. In addition to preserving a semantic and syntactic similarity of same words, we want word embeddings to capture the context of paragraph or a previous sentence. So according to a previous sentences or a previous paragraph, it will calculate the semantic and syntactic similarities property of each word and preserving the data in the feature representation, right? Let's understand with a very simple example. The sentence is, a tiger is eating while a lion is sleeping beneath the tree. Here the two subjects obviously tiger and lion. So if we switch these subjects, so the sentence will be, a lion is eating while a tiger is sleeping beneath the tree. Right? The both sentences maintain semantic relationship as well as the syntactic relationship, right? Here tiger and lion are both examples of animals obviously, and the sentence is also correctly logically correct, right? Similar to how it preserved grammatical relationships, the sentence likewise preserved syntactic relationships. So ultimately word embedding is very useful to preserving these relationships, right? In order to achieve that kind of semantic and syntactic relationship, we need to perform these two steps, right? The first one is mapping a word in a sentence or a document to simple numbers. So basically, we have to map a word with another word in a sentence, or we can say document, and convert it into the simple number, which is we can also say it a vector, right? And second is we need a large representation of those numbers that can represent both semantic and syntactic properties, which means we should have a vectors which is already trained, and it has a semantic and syntactic properties of these kind of numbers, right? We can also say is a features. So let's understand what this second statement tells us. For example, we have a vocabulary of 5,000 words and we need to perform word representation of the word king. And here king word is placed at 4,000 position in a vocabulary. Then our representation would be 0, 0, 0, 0, and only the position of 4,000 we have a 1, and the rest of position we have a 0. So obviously it is very sparse matrix, right, and highly inefficient. So to overcome this problem, word embedding has a concept called feature representation. So here we take all the words from the vocabulary and convert them into a numerical form based on some features, right? So the biggest question is what are the features, right? So features is nothing but the already trained vectors here. Let's understand with an example. Suppose we have 1,000 words in a vocabulary. So here you can see the man, woman, cat, all are the words in the vocabulary at a various position. Suppose man at a 700 position in a vocabulary, woman at a 5 position in a vocabulary. And here you can see human, animal, gender, royal, which is a features of our word embedding, right? These are the features, or we can say categories, right? So the larger feature representation with semantic and syntactic property are already available in Keras, Word2Vec and other libraries, right? As I have told that these already trained vectors, or we can say features, are available in many of the libraries. So we don't need to worry about to make these kind of features, right? And these features can be anything. Here we put the 4 features that can be other also, like age, or we can say jungle or cricket, anything, right? So here how word embedding is calculated or converting this sparse metric into the dense metric. Here you can see the word man, for example. So and our feature is human. So obviously man word is highly correlated with the word human, right? So here the value of man is obviously higher, right? Likewise woman is also highly correlated with the word human, so it has also a higher value. The negative sign doesn't represent the negative value, it just tells that it is a opposite direction, right? Like here you can see cat word is not related with the human, so it has a lower value. Like a lion also lower value. King and queen also highly correlate with the word human, or sorry, feature with human, so they have also a higher value. And likewise boy and girl also have a higher value, as those are very connected with the word human. Now here you can see, well, while correspond to the animal word, cat and lion have a higher value and rest as a have a lower values, right? Likewise gender and royal also, you can see royal word is highly related with the king and queen word. So word embedding is, now you can understand that it is highly efficient, as it convert higher dimension into the lower dimension. It convert sparse metric into the dense metric. Also it preserved semantic as well as syntactic relationship between the words. And you can hear, if you have noticed, man word has a value suppose 0.19 and woman word has a value of 0.93, which is highly connected, or we can say most similar. Here you can see king also and queen values also highly similar. So word embedding is also helpful to find the similarities between the two words, right? So there are a lot of advantages of using word embedding as compared to other feature extraction techniques like a bag of word, or we can say TF-IDF, right? I hope you got the idea how word embedding is exactly work and what are the advantages of word embedding. Now let's understand with a real world application. Suppose we have to find out the analogy detection. For example, here I have mentioned that if the word man, then what is the similar word with the man? So here the answer is woman, obviously. Then if the word is boy, then what is the similar word with the boy? So as we know, the answer would be the girl. So let's see how word embedding is help us to find out the word get girl, right? So here you can see we have a four word, and here we have a features, right? Human, animal, gender, royal, and it might be age, and suppose student, right? Professional. There are a lot of category, or we can say features, and here we have a values. So obviously you can see the human is related with the man and woman, so they have a higher values, right? Animal is not related with these words, so they have a lower value. Likewise, as we have computed these values, right? So to find out the similarity between these words, we have to apply similarities techniques such as cosine similarity or Jaccard similarity, or we can also apply the distance method like Euclidean distance, or we can say Manhattan distance, and there are many distance methods also available in mathematics, right? For the simplicity, we just subtract these two vectors. So here you can see the value of 0.90 minus minus plus 0.97. So obviously the value is approximately 1 point something something, and here minus 0.001 minus minus plus 0.002. So here we got the value approximately 0 point something, right? So here you can see only the first value is approximately 1, which is we can consider as a 1, and the rest will be 0. Likewise, in a boy and girl scenario also, we got the first value is 1 and rest of will be 0. So here this way word embedding help us to find out the similarities between the words, or we can say find out the analogy detection. So here as you can see, man and woman is highly connected with the human. So as a correspond to the human word, we got if word word man is similar to the woman, then obviously boy is similar to the one, as both values are 1 and rest of are the 0. I hope you got the basic idea of how word embedding is work, what is word embedding, how it is useful, what are the advantages of word embedding, right? So now hope you can understand that why word embedding is highly efficient and used in every SOTA model, which means state of art models in NLP. Now in the next lecture, we are going to implement this word embedding technique